Hello, class. This is a module for investigation 5. So we're gonna continuously doing the growth and decay factors, and then but we're gonna do the n unit this time. Okay, so we already I kind of introduced the last investigation too. So for exercise 1 through 2, the determine the specific growth or decay factor, percent change and initial value for each of the following exponential functions. So number one. This is growth functions because of the you need to check the number inside. Okay, so 1.24, which is greater than 1, that's a growth factor, and the number 2, which is 0.874, which is less than 1, that's a decay factor. Okay, so that's how you recognize the factor. Okay, so the growth factor is 1.27 24, sorry. And then as a unit, so this is actually the one that they put here. So I just put whatever that is, okay? So as the growth factor, which is I need to put 1.24, and then with a 1, and then you just need to multiply the units they choose here. So this is going to be about 1.24 to the half power, and then it's about 1.114. For the 2-unit growth factor, same thing. Use a growth factor, but this times 2 units, so 1 times 2. And then you're going to get 1.24 square, which becomes 1.5376. Okay, let me actually make us the dinner. Okay, and then we're going to change the 2%, find the 2 unit percent change. So first of all, we have to use this to make a percent, okay? So which is becomes 153.76%, and you always subtract the 100, which is about 53.76%. That's a percent change. And the initial value is always a number in the front, okay? So 9.5. So for the second problem, but this times actually you can write this problem as 0.46 of 0.874 to the fourth power and then to the x powers outside, okay? So this whole thing is actually the growth factors. So growth factor should be all this, the whole thing. So in order to find the 1 unit decay factor, we just put out the 0.874 and then with the fourth power and times by 1/4, which is 0.874 to the power 1, which is that's it. And then the 1 unit growth factor means 0.874 to the fourth power times 1, and then you get the 0.874 to the fourth power as it come out as 0.584. 5 unit growth factor 0.874, 4 times of 5, which is 0.874 to the 20th power, which come out as 0.06764. And the initial value is going to be the front numbers, okay, 0.46, okay? Okay, number 3, determine the specific growth and decay factor, percent change, initial value, and function formula for each of the table model by the exponential function. So this time, I am using the table. So we have to find the decay factor first. So decay factor, which means you have to use the ratio, right? So 10.24 and divide by 16. So 10.24 divided by 16 is, I got 0.64. So, but 0.64 is the already 2 unit growth factor. Okay? Because x is increased by 2. And this is another 2, right? Now, I want to find the 1 unit percent change. So, which means from the 0.64. And then the 1 unit is actually half of 2, right? So which gonna be the 1 over 2 and then become 0.8. And then 3 unit decay factor, which is now the 0.64. And then the 2 unit growth factor, the 3 unit growth factors, right? So this is gonna be the 3 over 2. So 0.64 you got 0.5112, okay? Or you can use the 0.8 to make the third power too if you want. And the half unit decay factor, which is yeah, so now easier way you can do it. I mean, you do the same thing, all right, but you can do as you can pull it out the 1 unit. Okay, 1 unit growth factor to change to the so which is the same as 80% for the B, and then 80 minus 100, which is about negative 20%. And then half unit decay factor, which is you have 0.64, and then you have actually the 1/2 of 2, which means 0.64 to the 1/4 power. So 0.64 to the 1/4 power, 0.894. Okay. And then initial value, which is, well, yeah, we have a good thing is x equal to 0, so 16 is. And then formula of the function is going to be the initial value times. And then I want to use the 1 unit, the decay factor, which is 0.8 to the x power. Or if you want to use a 2 unit decay factor, which is 16 of 0.64, and then x over 2. Okay. So that's a formula. So either one is actually defined. All right, 3 unit growth factor because x is actually increasing by 3. So yeah, you can call this as a 3 unit growth factor. Okay. So what you do is just divide 278.2 and divide by 260. And then I am getting as 1.07. And then 6 unit percent change. Okay. So 6 unit percent change. Which is when you have 1.07, and then you just need to, 6 is a twice of the 3, right? So, or you can say 1/3, 2 times by 6, but it's going to be, so this is, to change the 1 unit growth factor is 1/3, but you just need it twice, okay? And then you get the 1.1449. And then, but we have to change the, we have to find the percent change, right? So change the percent as 114.49. And then you subtract the 100, which is 14.49%. And then 1 unit growth factor means you got 1.07 and then 1 over 3, which is that's a 1 unit growth factor, so which is 1.023. And then 4th unit growth factor, so you can use either one. So if you use a 1.023, now you can just put the 1/4 power, which is 1.0057. Or if you use a 3 unit growth factor, you can just say 1/4 of 3, which is, you can also use a 1.07. And then 1/4 unit over 3, which is 1.07 to the 1 over 12, which should be the same as 1.0057, okay? So 1.07 to the 1 over 12, which is, yeah, it's the same thing. And the initial value, which is the problem is there's no initial value here, right? Because we need to find x equal to 0 to find the one number matched to this, okay? So I'm using the 260, but I'm going to use the 1 unit growth factor, which is 1.023. So 260 divided by 1.023. And then I have 254. 254.154. And then formula function, it's a g, sorry. G of that is 254.154. You can use either one, but I would like to use a one unit growth factor, so 1.023 to the x power. Okay, and then also you can use as 254.154, 1.07, and then x over 3. So either ways you can do this. All right, number 5. Determine the, now we are using the graph to find the growth or decay factor or percent change, initial value, average rate of the change, and the function formula for the exponential function with the graph. All right, use the graph to complete the following, because between the 2x value is increasing by 2, so we can call this a 2 unit growth factor. So if you pick the 40 and divide by 15.625, and then it'll be 2.56. So that is a 2 unit growth factor. So we have 2.56, and then so 6 units is 3 times of 2, 3 times of 2, so we just need to beat the cube. Then 16.777, which is, that's how much increase every 6 units. And then 1 unit percent change, which is I need to find the 1 unit growth factor. So 2.56, and then 1 unit means 1 over 2, right? Which is the same as 1.6. So 1.6 is 160%, subtract 100%, which is 60% increase every 1 unit. The half unit growth factor, the growth factor, of course, is gonna be we got the 1.6, okay? So 1.6 to the half power, which come out as 1.265. And 3 unit growth factor, now 1.6 to the third power. And then I got 4.096. Initial value, okay, yeah, I don't want to really guess. It looks like about 25, but I don't want to guess this. I'm using the 40 and then divide by 1 unit growth factor, which is 1.6. And then 40 divided by 1.6 come out of 25. Yes, a good guess. And then formula for that function is initial value of 25 and then 1 unit growth factor, which is 1.6 to the x power. Or you can say 25 of 2.56 to the x over 2. So either way is fine. So average rate of the change out of x with respect to the x as the value of the x increased from -1 to 1, which is the average rate of the change about the slope. So which means we are looking for the slope of the secant line. So through this one. So we're looking for this slope. So same thing. So which is using the y2 minus y1 over x2 minus x1. So y2, I want to say 40, subtract the 15.625, and then 1 minus -1. And then I get 24.375 over 2, so about come out as 12.1875. Explain how to interpret the value of the you find in the h. So we have to say constant rate of change needed to have a change in y of 23.375. No, 24 point, what am I saying? $24.375. Okay, oh, let me check again. 40 minus 0.625, yeah, 24 point. And when x changes from -1 to 1, okay. All right, so that's all for the number 5. So I'll show you how to find out the n unit growth factor. Okay. All right, so let's look at the next page. All right, so now you can try the number 6 if you want, okay? But I want to skip that one right now, okay? All right, so for the, I'm going to go for number 8. So determine the growth and decay factor, percent change in initial value, and the function for the each exponential situations, number 8. After having 1.97 million people in 2010, the population of the city has been decreasing by 4.2% every 3 years, okay? So what is a 1 unit decay factor? So 4.2%, which means from the 100%, you're decreasing as 4.2%, which is I'm getting as 100 subtracting 4.2, which is 95.8, which is 0.958, okay? So that actually the as a decay factor. So it's gonna be the, but for every 3 years, okay? So I have 0.958, but that's every 3 years, so we have to change the 1 unit growth factor, so 1/3. And then 1/4 year percent change this time, right? So what I do is I need to change the 0.958, which is 1/3 power is the 1 unit decay factor. And then I'm going to multiply by 1/4, which is I got 0.958 and then 1/12. So that is the, and then if you compute this, I got 0, okay, I got 0.9965. So which is chain as 99.65, and then 99.65 subtract 100, and then I getting negative 0.35, okay, percent. All right. And then initial values, which is starting from the 1.97 million. And then function that I can make that as is 1.97 million of the, you can just use a 0.958 and then x over 3. So this actually that makes the 1 unit growth factor, which is this actually the, if I go back to the a, it becomes a 0.9862. So either ways you can use, okay? But this is going to be the power one, okay? All right, so that's all for the module 4 and investigation 5. So thank you for listening.